Okay, the Maxlog M-8900. The no transmit power complaint was confirmed as receive, but no transmit output power. So, remove the covers, just so you can see what this little guy looks like. It is a multi-layer board, and we have components on both sides, which probably scares the bejeebas out of a lot of people, and rightfully so. And this is a good example of why. If you don't know what you're doing, you really need to either not work on this type of stuff, or you need to learn how to properly work on it. The soldering that was done on this thing was, yeah, sloppy would be being kind. So, as you can see, there's lots of empty holes here, and there's, as well, lots of missing parts. That's because all the parts are laying over here. So, first thing I did was check for voltage. So, here's our, well, actually it's a tip. Let me pull it up here and look at it. They got it in there. Yeah, they've got a tip 36, but the schematic calls for a 2SB, what, 688, I think. Yeah, 2SB 688. But in any case, what we should have is your 8 volts out here. So you've got your 13.8 here, 6.8 volts regulated voltage out. Should come down through, I'm trying to look through the camera while I'm pointing at this. Should come down through coil L8 here, which is this one. That's the first one, or the one that's goes over here. Should go, let me get a pointer here, get my big meat paw out of the way. But anyhow, your voltage should come down through L8 and then to each of the MOSFETs here. So we should have 8 volts here and 8 volts here. And likewise with the driver MOSFET. Same thing, 8 volts, regulated 8 volts out through this coil, down, and to this MOSFET, which is the drain. Okay, now when I probed, I had 13.8 here, I had my voltages were correct here, voltages were correct here, checked the driver, actually had good voltage here, and when checked with a oscilloscope, I had RF in and larger RF out. So the driver would appear to be working. Come over to the dual finals and check along the way here. We've got 8 volts, 8 volts. We get to L8, we've got 8 volts. Check on the other side of L8. I was measuring 8 volts. So I was probing literally on the tip of this lead. You know, on one of these leads. I was actually had my probe right on the tip of it. And I had 8 volts right here. But I did not have 8 volts here. So, if we look at the radio, there, we're going to need a little bit of supplemental lighting here. Let me get it flipped over. So the drain is in the middle of both of these. Okay, now you can see the drain is not connected to anything down here on the underside. You've got these little pass-throughs, but nothing on the underside. I flip the radio back over. That's this one right here. We can see that little pad comes up through right here, but it's not attached to anything. Well, it's supposed to be. Well, it is, but it's, like I say, a multi-layer board. It should be hooked up here. And now if I probe right now with an ohm meter from this pad to this plated through hole, I do have continuity. But when the coil was installed in here, I did not have any continuity, measuring off the tip of this. And what it was bad solder. And what somebody, this has been, I think the customer said this radio has been worked on 4-pore solder joints 2 times before. Then it's obvious. And it looks like they probably, being this is new manufacture, there's no doubt in my mind all of the solder that's currently on this board is lead free. The problem is it looks like someone tried to, or used lead-free solder to do their reflowing. Personally, I do not like using lead-free solder. I have some here, probably like 4 or 5 pounds of it, and if I die in 50 years, I will probably still have 4 or 5 pounds of lead-free solder, and it's going to be the same solder that I have right now, because I almost never use it. I don't like it. Not for hand soldering. Reason being, you need higher temperatures. It's so much easier to get good solder joints with leaded solders. It's not that I'm anti-environment. I've often said that. It's not that, I'm not using this stuff, to pollute the environment. I just use it because in repair work, I find that the lead-free solders just aren't as reliable. They're more difficult to work with. I can get beautiful, well, matter of fact, I can show you, actually reflowed these 3 solders. Well, actually I did not reflow them, I should say. These were nasty looking too. Big balls, they were white, very crystalline looking on the structure, and that's not what you want to see. That right there is what you want to see. If I can get it to focus that close. Nice, shiny, looks like a mirror. No inclusions, there's no bubbles. It's a nice little mirror surface. That's what you want to see. The kind of soldering work that someone has done in this thing, and I have not fixed any of this yet, you can see globbed up down in here. I guess they actually cleaned this off with some isopropyl because they had all their flux residue was still in here, but these are all rough. There's whiskers of solder hanging off of stuff. I can look at some of these other ones here. It looks like they probably reflowed. I don't know why, but they reflowed. What is that? RF shield can. I don't know why they would have reflowed them. And a couple here. But you can see they're not nice and shiny. They're rough textured. Yeah, just overall sloppy work. I mean, you can see, it's fairly easy to see what they resoldered because, like I say, they didn't clean off any of their flux residue. So anything that they had resoldered still has flux on it. Now, this is partially cleaned off because, like I say, I did clean this area off. But, yeah, like I say, rough texture, it's sloppy. So the proper procedure here when I do stuff like this, if I have, especially on multi-layer boards, if I suspect bad solder joints or I test it and find that, I have continuity where on one side, but it's not making it through to the lead or from the lead to the, to a pad, I do not reflow them because I find that's not a good procedure to use. The best procedure to use when you have bad solder joints on even just regular double-sided boards, anything but through-plated holes, the best thing, honestly, to do is completely desolder it using a proper desoldering iron. Okay, and we're using, right here, vacuum-operated. And of course I had to stick my big monster hole tip one, so, that's another thing when you're using these, always use properly. Trying to do that through the camera is not working very well, but you can see properly sized for what you're desoldering. But completely remove the component, and I will also, as well, because you see there's still some blobby, gunky looking solder residue on there, so I'll actually clean that off so they're nice and fresh. I'll do that to all. Well, trying to hit the hole looking through the camera doesn't work very well. As it gets really, really hot in my fingers. Luckily, I got thick skin. But in any case, so I've gotten basically as much of the original solder residue off of there as I could. Same thing here. I desoldered it, and I'll even clean those pads off a little bit better. I'll actually add a little bit of liquid flux, and then clean those off a little bit better. But what I want to do is remove all of the old solder, because what I want to happen is when I resolder it with my leaded solder, and this is actually this is not just tin lead. This is a silver solder. I use silver solder for everything, especially when you have stuff like this where you're having bad solder connection problems. The silver solder has a higher tensile strength, so by using that, that's going to help prevent this from happening again in the future, so the customer does not have a fourth time he has to get his radio repaired. When we do repairs, we like return customers, but we don't like return customers that you're fixing the same thing all the time. If they have a problem, fix it. That should be the last time you ever fix it, you know. So, like I say, best procedure here is just remove the parts and start over. Like I say, there's a couple of other solder joints I need to straighten up on this board, but yeah, it looks like everything's fine. You know, like I say, I have RF power out here. I have RF power going in to both of the finals, so it's, you know, coming out the driver into the finals. I just don't have anything out of here because I have no voltage here. So I had voltage here and nothing here. So it just wasn't quite making that leap across. So we'll get these coils cleaned up, and then I'll continue the video and show this thing back up and running with properly soldered connections. Okay, and speaking of bad solder connections that I need to fix up, I forgot to point these out. You can see some of this glopped up solder on the top side right there, where someone, pull back just a hair here, it'll focus. Yeah, but anyhow, somebody resoldered these inductors, and yeah, you can see they it's just sloppy. Yeah, I was actually just in here with the swab cleaning off the board before I reinstall the coils, and I saw them. So yeah, those are two more. What I'll do is I'll remove them. The proper thing to do, like I say, to get a really good reliable solder connection is don't just try and reflow it. Remove all the existing solder. Doesn't hurt to add a little bit of liquid flux, and then resolder it with new solder, and you'll get a good reliable connection. Trying to reflow this stuff, mixing different compositions of solders, you're never going to end up with reliable solder joints. So give me a few minutes here. Okay, so I'm ready to, I have all of those coils reinstalled now. You can see I've cleaned up the underside of the board. Now, when you're installing normal through-hole components, normally you'd bend the lead over slightly, slightly clinch it over so you can flip it upside down and then do your soldering. Well, of course, these are really, really heavy gauge wire that these coils are made out of, and they've already been, installed and then cut off. So there's not really anything to bend over, and even if there was, like I say, it's really heavy gauge. So it's the easiest thing to do here. You notice there's something yellow hanging out underneath. There's a towel underneath. So what I did was, from the top side, installed all the components, then kind of balled up a towel, pushed it down in there. So that's the radio. You can see I can push down on it, but that towel is on the underside holding those components from falling out. Just a little tip one way. That way you don't have to do one trying to hold it in with your finger, bore it up on its side. That way you can install all those components, come in and do all your soldering at one time. Now, like I say, we knew these were troublesome to start with, so we're going to add a little bit of liquid flux here to every single one of these connections. We want to make sure we get really, really good cleaning and really good bond on all of these. And I always say with flux, too much is always just enough. Never have too much flux, because you can always clean it off if you get too much. Yes, there's flux in the solder I will be using, but like I say, I'd rather be better safe than sorry, because I never want to see this radio again for the same problem. So, now another thing I have done is switched out to a little bit larger tip on my soldering iron, because they're heavy gauge wire. We've got multiple layers. We want to be able to get good solder connection the whole way through the board, so I picked up a little bit bigger tip so it had a little bit more thermal mass, and I can do my soldering quickly and be done with it before doing any circuit trace damage. So let me just move the camera down and back a little bit, kind of go like that, way it's kind of out of my way so I can get down here. A lot of times when I'm doing stuff like this, I'll hop around and do, maybe a lead off of each component. That way I'm not overheating any one individual component. But as you can see, even before I clean the board off, you can see how much nicer and shinier my solder connections are. And like I say, That's because I'm using a good solder. And it's not that it's silver solder that makes it shiny. It's because it's a properly done solder connection. If you're just using even regular lead tin solder, your solder connection should still look like that. Very nice and shiny, a smooth surface. Should not be, I often say crystalline looking, which is almost the appearance you get with cold solder joints, or very rough in texture. Like I say, it should almost look like a mirror. And I'm not sure how well it's showing up in the camera, but as you can notice while I'm soldering these components, you'll see the solder, as I'm first added, and then it starts to disappear. Well, that's because it's going down through the circuit board, going through that through, or the through hole. So, okay, looks like we got them all soldered up there. Now I have to reinstall these other two. That was these two little guys here that I removed. And I'm not going to be soldering them with this big monster tip, so that's why they're not in at the moment. So, I just reused one of these Q-tips. I'll do a final cleanup a little later, after I verify everything works. Like I say, we always want to clean off, make sure our solder connections look good. Like I say, working on these circuit boards is not for the uninitiated in surface mount technology, because these radios right here use some very small parts. Now, granted, they're not the smallest there are, which are, what, 0.100.5, or it's 0.100.5, but they're really teeny tiny. Actually, where in the heck is it? Okay, where in the heck did my flux brush get to? There it is. But like I say, it's not for, I guess what you could say, the faint of heart. If you don't know what you're doing, you can do a lot more damage than you can good when working on stuff like this. So, the whole key here is know your limits. If you don't know how to work on this kind of stuff, don't. You may be able to diagnose the problem, even. You may have the technical skill to do the troubleshooting, but if you can't do proper soldering, you stand a really good chance. That's what I'm seeing a lot on a lot of these radios like this. And it's not that the people couldn't do a proper soldering job if they just practiced a little bit. That and got some other equipment. For starters, they're using their basically their granddad's soldering iron to work on a lot of this stuff. So there we can see, but if you look at those solder joints, you can see how nice and shiny they are. And, no signs of bubbles, there's no, uneven texture, all of them. They're like, you can even see when I bring the tweezer in there, see that reflection in there on the left side of that solder joint. That's what you want to see, little mirrors. But like I say, I can grab a mechanical pencil, and this is a what is this, a 0.5 lead. So, here's a 0.5 right there on the pencil, okay? And compare that to, let's pick some of these tiny little parts here, like right there. That's a component, that little tiny black spot. Notice it's just a hair wider than a piece of pencil lead. 0.5 pencil lead at that. We're not talking a standard, number 2 pencil. That is dwarfed by a normal pencil. But yeah, like I say, if you don't have the proper tools and you're trying to solder this kind of thing, boy, man, you can really screw up some circuit traces. So, best thing to do, get yourself some practice boards and practice soldering stuff like this, because the last place you want to be practicing is on a customer's radio. So let me get this other 2 coils installed, and we'll fire it up and see if she works.